All right. Well, I think it's 2 minutes past, so I think we will get started now. So my name is Gregory, and I'll be running our session today. It's all going to be about getting started with DevOps metrics. This session aims to provide an overview of DORA metrics and other metrics within GitLab to help identify opportunities for greater efficiency and correlating those opportunities with business value, connecting the entire organization with a common goal and vision. So for our agenda today, we'll start by discovering DORA metrics, what it is, why it's important. Then we'll go through value stream analytics, insight dashboards, where you can find them in GitLab, and then round up with additional metrics available on GitLab. If any questions come up throughout the session today, you can drop them in Q&A, and one of my awesome colleagues will get you an answer as soon as possible. All right, so DORA metrics. Let's get this started. So taking a step back and talking about what DORA metrics are and where it came from. So DORA stands for DevOps Research and Assessment. After 8 years of data collection and research, DORA's Accelerate State of DevOps Research program has developed and validated 4 metrics of software delivery performance and a 5th metric, reliability. So in this session, we'll cover the first 4 DORA metrics, which are deployment frequency, lead time for changes, mean time to recover, and change failure rate. Why do we care about tracking DORA metrics or metrics in general? Well, return on investment for DevOps can be very tricky, since it's hard to put a price tag on a process, not a commodity. But DevOps requires a huge investment in every organization, and often time executives. So they want to know what they're getting in return. So these metrics can help improve DevOps efficiency and communicate performance to business stakeholders, which can accelerate business results, after all. So let's talk about the metrics themselves. So deployment frequency is the average deployment frequency to production. Lead time for changes is the median time it takes for a merge request to get merged into production from master branch. Change failure rate is the percentage of deployment that caused an incident in production. Time to restore service is the median time an incident was open on a production environment in the given time period. That's roughly what they are. Everyone who is contributing is involved in generating the metrics. Absolutely everyone on a team. So this includes developers, testers, managers, security, everyone. That's the beauty of it. So where are you going to find these? So in GitLab, you can find them in CI/CD analytics, group level value stream analytics, insights, and also APIs are available for all 4 DORA metrics. And we're going to go through all of them today. So DORA metrics can be found under CI/CD analytics at both the group and project level. Once on the CI/CD analytics page, there are different tabs on top where you can toggle between to see the charts and metrics of each. We'll first explore deployment frequency and then following metrics. Under deployment frequency, we'll see that all successful deployments to production. So this measures how often you deliver value to end users. Higher deployment frequency means you can get feedback sooner and iterate faster to deliver improvements and features. GitLab measures this as a number of deployments to a production environment in the given time period. In the chart shown, here's an example of how deployment frequency is visualized. We have the option to view data within the last week, month, 90 days. So this red line across a chart indicates our average. Next, we can find lead time for changes under the same analytics page by toggling the next tab. Here, we're looking for the time it takes for committed code to successfully run in production. This reflects the efficiency of CI/CD pipelines. In GitLab, a lead time for changes calculates the median time it takes for a merge request to get merged into production. And this is measured from code committed to code successfully running in production without adding the coding time into the calculation. So we're calculating a median instead of average, since there are times that no deployment or production happens, for example, over the weekend. And we wanted to give a true sense of what the lead time for change really is. Over time, this metric should decrease while your team performance should increase, ideally. This metric is support at the group level and project level. In the chart shown, the gray dotted lines show no merge requests were deployed during that period. Similarly, change request rate can be found under the CI/CD analytics page on the next tab. And this is available at both the group and project level. The change failure rate chart shows information about the percentage of deployments that cause an incident in a production environment. For example, this can be a deployment failure, an incident, a rollback, or a remedy. This is measured as a number of incidents divided by the number of deployments to a production environment in a given time period. But in this case, you must use GitLab incidents for incidents to be captured. So that's the only caveat for that. And for the fourth DORA metric, time to restore service can also be found on the CI/CD analytics page. This shows information about how long it takes an organization to recover from a failure in production. It'll give us a better understanding of our software stability and reliability trends over time. GitLab measures this as an average time required to close the incidents in a given time period. This assumes that all incidents are related to a production environment. And it also assumes that incidents and deployments have a strictly one-to-one relationship. An incident is related to only one production deployment, and any production deployment is related to no more than one incident. That is not confusing at all. In addition to viewing the DORA metrics in UI, you can also get project level and group level DORA metrics through the API. And this could be helpful if you want to see metrics beyond the last 90 days. You can enter the date range since UI shows 7, 30, 90-day view. So we took a quick look at the CI/CD analytics and the DORA there. I know that's quite a lot, and this is confusing, and we have extensive documentation to go through it. It took me quite a while to get accustomed to all that. So don't be alarmed if you can't remember it. If you can, and you're already an expert, brilliant. So next, we'll take a look at the value stream analytics. This is a bit heavy, so bear with me. So value stream analytics collects and shows data across the entire software lifecycle. So with no integrations to be managed. So this is a no-code value stream analytics dashboard with single-click drill down for all tiers. A value stream is the entire work process that delivers value to customers. So this helps provide insights into items that took the most time in this stage and drill into, to find what caused that particular delay. You can sort and filter labels, timestamps that you're interested in investigating. You can even test and compare different approaches over time to see which processes improvements helped efficiency and which ones cause additional idle time. To view value stream analytics for your groups, you must have at least a reporter role, since value stream analytics only show custom value stream created for your particular group. You will need to create a custom value stream there. The overview dashboard, similar to this one showed here, has key metrics and DORA metrics of group performance. So depending on the filter you will select, the dashboard will automatically aggregate DORA metrics and display the current status of the value stream. And it will help if you want to measure the amount of time it takes to go from an idea to production. You can also measure the velocity of a given project and bottlenecks in a development process. Again, what stages are taking longer to complete. And when we combine both DORA and value stream analytics, DORA will help you benchmark against the industry standards, and the value stream analytics will help you identify, improve, and better those DORA metrics. So when you create a value stream, you can use GitLab default stages and hide or reorder them to customize it align it with your own development workflow. You can also create custom stages in addition to those provided in a default template. So here we have an example of how to edit an existing value stream, and we're using scope labels for the workflow stages. Here's an example of the 4 DORA metrics and how they look in the value stream analytics. This helps you visualize the engineering work in the context of end-to-end value delivery. One thing to note is lead time for changes is not the same as the lead time. In the value stream, lead time measures the time it takes for work on an issue to move from the moment it's created to the moment it's delivered, the issue closes. So let me say that again. So lead time for changes is not the same as lead time. So in the value stream, lead time measures the time it takes for work on an issue to move from the moment it is created to the moment it is delivered, issue closes. So here, in this example, we show you how you can use value stream analytics to find bottlenecks in workflows. For each stage, a table list displays the workflow and items filtered in context of that particular stage. The table provides a deep dive into the stage's performance. And here we're looking at the staging stage. And below we have a merge request, last event, duration column. From here, we can take a look at the table to see there's a merge request 3 days ago that took about 8 hours, which is significantly longer than the ones below. And we can investigate further. So, and this is available on GitLab from versions 14.4 and newer. Now, let's take a look at the inside dashboards. More metrics. So insights, they give you the option to configure a custom report for insights into group processes, such as an amount of issues, bugs, merge requests per month. You can configure insights to export data by your group's activity, such as triage, hygiene, issues created, or closed in a given period. You can also see the average time for merge requests to be merged. You can also create custom insight reports that are relevant for your particular group, depending on your requirements. And this is available at the group and project level. So this is an example of an insights configuration file. It's showing a single definition that displays one report with one chart. In the file, the configuration parameters define the chart behavior. Each report has a unique key and a collection of charts to fetch and display. And each chart definition is made of a hash composed of key value pairs. The GitLab insights.yaml file has a YAML file where you can define the structure and order charts of a report and the style of charts displayed. For example, bar chart, line chart, so on and so forth, in the report of your project or group, which is handy. So here, we can also see DORA metrics under insights. So we added DORA query parameters to insights. You can track metrics improvements, understand patterns in metric trends, and compare performances between groups and projects. Insight reports are configured with a YAML file, similar to the example that was shown earlier. It can be shared across the organization as a single place for everyone to see the same metrics in the relevant context. So this new dashboard provides strategic insights into the metrics that help decision makers identify trends and patterns, optimize software delivery. So the first iteration of GitLab value stream dashboards is pretty much focused on enabling teams to continuously improve software delivery workflows and benchmarking value stream lifecycle to value stream analytics, DORA metrics, and vulnerability metrics, which is new. And you can use the value stream dashboard to track, compare those metrics over a period of time, identify downstream trends early, understand security exposure, and drill down into individual projects or metrics and take action for improvements. So this is a fairly new one. And our initial case here is focused on providing the ability to compare software delivery metrics. So this comparison can help decision makers kind of get an idea where projects and groups are improving or not. And the value stream dashboard includes DORA metrics, value stream metrics, kind of flow metrics, and vulnerabilities metrics, which I'm also going to cover in a second. The value streams kind of dashboard also allows you to aggregate data across many different APIs, track software performance, DORA and flow of value across your whole organization. So it's a great dashboard. Now that there's more metrics, let's take a look at them as well. The DevOps adoption. So we have a DevOps adoption report. And this report shows you how your groups in your organization adopt and use the most essential features of GitLab. So for example, in red, you can see development category with approvals, code owners, issues, and merge requests as the features below it. A feature is shown as adopted when a group has used the feature in a project during that period. This includes projects in a subgroup of the group as well. For example, if an issue was created in a project in a group, the group has adopted issues in that time. DevOps adoption can help identify specific subgroups that are lagging in the adoption of GitLab features. So you can guide them on their DevOps journey internally. You can also find subgroups that have adopted certain features and provide guidance to other subgroups on how to use those features. Essentially something that we do at GitLab anyways, but internally it's also important to keep an eye. And you can also use DevOps adoption to verify if you're getting the return on investment you expected. So it's always helpful to keep an eye. Now, code review. Using the code review feature in merge requests, you can look at the time it takes for a merge request to open to the time it's merged. You can find this information on the code review analytics to see the longest running reviews in open merge requests and take action on the individual merge requests. So for example, a high number of comments or commits may indicate the code is too complex, or maybe authors require more training. A long review may indicate types of work that move slower than other types, or opportunities to accelerate your development lifecycle. Fewer comments and approvals may indicate staffing requirements. And this kind of helps reduce overall cycle time and help you give insights and make improvements within the teams. And code reviews analytics can be found at the project level. With contribution analytics, you can get an overview of the contribution events in your group. So this page allows you to analyze your team's contribution over a period of time. And you can identify opportunities for improvements with members who may benefit from additional support. There's three graphs that illustrate the number of contributions made by each group member. You can see push events, merge requests, and closed issues for each group member. You can filter by many other things, pushed events, open, close, merge requests, and so on and so forth. One thing that we do not advise is getting into kind of a competition. Although it's useful to see who some of the more active members are, there's also a view of, if you go to your profile on your instance, where you can see the heat map of your activity. You can see when the folks were busy or less busy. So and this can be useful for discovering team members that might be contributing too much and are at risk of burnout. And alternatively, you'll find folks that are disengaged or not contributing enough. So there's always a risk of both. So merge request analytics. It shows you the number of merge requests your organization merged per month. It's very simple. It also shows the average time between merge request creation and merge. And see information about each merge request. You can use this to identify low or high productivity months and the efficiency of your merge request process and code review process as well. And this is available at the project level. So repository analytics. It shows you how you use and how many programming languages are used in the repository and additional Git repositories information such as code coverage history from the last 2 months. For example, in addition to seeing the programming languages used, you also find average commits. There's also an option for you to download code coverage statistics raw data in CSV. And the screenshot shown here is actually of our GitLab repository. And since all our backend code is in Ruby, it makes sense that the big chunk is in Ruby, as shown. So operations dashboard. Users can create their own individual operations dashboard where they can monitor many different projects. The operations dashboard shows a summary of each project's operational health, including pipeline and alert status. This could be great for team leads or even group leads at a glance. If you see if the pipeline succeeds, or if it's currently failing or running. And you can also take a look at when the last commit was that particular group. So when clicking on one of the cards, it'll take you to a specific project, which is helpful to keep an eye on. Now, the environments. The environments dashboard provides a cross-project environments-based view that lets you see the big picture of what's going on in each environment. And from a single location, you can track progress, such as changes flow from development to staging, and then to production, or to any series of custom environments flows that you will set up yourself. The operations and environments dashboards share the same list of projects. Adding and removing project from one adds or removes a project from the other. This dashboard can be helpful because at a glance, you can view multiple projects. You can instantly see which pipelines are green and which are red. Then it can allow you to diagnose if there's a block at a particular point and there's a more systematic problem you'll need to investigate. To get this environments dashboard, you'll need to navigate to main menu environments. From there, you can begin adding your project. And last but not least, a couple more points about security insights. So security reports. So the security dashboard, using that, you will see the trends about vulnerabilities detected by the security scanners. And these trends are shown in projects, groups, and also the security center that we have recently added. The security dashboards show results of scans from the most recent completed pipeline on the default branch. And since dashboards are updated with the results of a completed pipeline that run on the default branch, they do not include vulnerabilities discovered in pipelines from other unmerged branches. So you can hover over the chart to get more details about vulnerabilities. You could display the trend over 30, 60, 90 days over time. And if you want, you can view aggregated data beyond 90 days when you use your API as well. GitLab retains data for about a year. So when it comes to security insights, the vulnerability report provides information about vulnerabilities from scans of the default branch. And you will see results of all successful jobs, regardless of whether the pipeline was successful or not. The report is available at the group and the project level. On that report, you can filter, set status, and drill to see details of each vulnerability. You also have the option to export details of the vulnerabilities listed in the vulnerability report itself. The format you'll export it is CSV if needed. Each vulnerability in the project has a vulnerability page. So for example, from the report, and we see here, we click into vulnerability and it will take us to a vulnerability page where we can see kind of more details about that particular vulnerability. On the vulnerability page again, you can take an action and change the status, resolve vulnerability if solution is available, view security training specific to that detected vulnerability, create an issue. After you create an issue, you can track actions against it, resolve it, to mitigate it. By default, you can create a GitLab issue. If you have a Jira integration set up, you can create a Jira issue as well. That's not a problem. So compliance report. It gives you the ability to see groups merge requests activity. It provides a high-level view of all projects in the group. So you'll use the report to get a list of compliance violations from all merge requests within the group. And you can also use the report to get the reason and the severity of each compliance violation, and a link to merge requests that caused that compliance violation. Apologies. So to view the compliance report for a group, And the user must be an administrator or have the owner role for the group at least. License compliance. Oh, that one's my favorite. If you're using GitLab CI/CD, you can use license compliance to search your project's dependencies for the licenses. And you can then decide whether to allow or deny the use of each license. For example, if your application uses an external open source library whose license is incompatible with yours, then you can deny the use of that license. You can select licenses to see additional licenses. When GitLab detects a denied license, you can view it in the license test page. So on the policies tab, you can view and modify existing licenses as well. So coming towards kind of the end here, and we have the dependency list. So this is kind of a big hot topic. You can use dependency list to review your project dependencies and view additional details about those dependencies. So this includes their known vulnerabilities. You can find dependency lists under your project menu and select security, compliance, dependency list. So this information is sometimes referred to as software bill of material or as BOM for shorter. So we recommend not changing the default behavior of allowing the secure jobs to fail, because the dependency list only shows the results of the last successful pipeline to run on the default branch. So GitLab dependency scanning or container scanning job must be configured in your product for you to see the project dependencies. So your project also has to use at least one of the languages and packages managers supported by Gymnasium, which is our scanner. And the dependency list shows the path between dependency and the top level dependency is connected to, if there's any. There are many possible paths, but the user interface shows the one that is the shortest, essentially. You also have the option to download your project's full list of dependencies details in JSON format. And I believe we have come to an end. There was quite a lot of dashboards that I've shown at you. And yeah, like I said, we have quite an extensive documentation that is covering everything. So I'm hoping that was a useful overview. And if you have any questions, yeah, please do ask. And thank you for attending. Let's see if we have any questions in the Q&A. I think we had 2 questions that were answered. Awesome. So we had a question about whether the features are available in the Omnibus installation, which they were. Mariana already answered. Thank you for that. Well, yeah, if there will be nothing further, thank you very much. And yeah, we're going to be wrapping up the session, so I'm going to stay for another minute or so, just in case there's anything. And if not, then thank you so much. All right, brilliant. All right, thank you, Mariana. I'm going to wrap this up now. Bye, everyone.